What's up, everybody? Welcome to my channel. Thanks for tuning in to Eric the Tutor. Today we're going to be going over Aldol condensation again. We're going to take it all the way. We're going to show the mechanism, and we're going to go ahead and get started, alright? So, the first thing we want to examine is, let's go ahead and look at this NaOMe. So, this NaOMe was giving some of my students some trouble. So, let's break that down. The Na is the spectator ion. We have an O that's charged, because we have 3 lone pairs on our oxygen, and that is attached to a Me. Me is a shorthand way for showing a methyl. So here's our CH3. This is what NaOMe looks like. Now we know that this O minus here is going to want to go and attack something, alright? So what is it going to attack? Is it going to attack the hydrogen here, the carbonyl, maybe somewhere on this benzene, or what about over here, the CH3, perhaps this carbonyl, or maybe somewhere on this benzene. The key here is we want to look for alpha carbons. So I see an alpha carbon here, I see an alpha carbon there, and an alpha carbon right here. But if we look at this alpha carbon and this one, there's no alpha hydrogens coming off of them, right? There's 3 bonds here. Carbon has the double bond here to make its octet just fine. Same thing over here. This carbon's got a bond to the C, and another C with the double bond, so there's no alpha hydrogens there. The reason we're looking for an alpha hydrogen is because that's going to give us our most acidic hydrogen. So I know coming off of this carbon, there's an alpha hydrogen right there. Of course, there's 2 other hydrogens that give us a total of 3 hydrogens coming off of there, but we're only interested in attacking one of those, okay? So if we go ahead and do that, then we get a structure that looks like the following. It's going to show some resonance. Now, it's not going to matter which resonance structure we decide to choose, so we just added a new lone pair onto this guy to give it a negative charge. If I go ahead and show the resonance for this structure, resonance structure looks something like, push these electrons onto there and push that oxygen up to give us a resonance structure that looks just like this. Now we can choose to use either of these two. We can use this one, or we can use this resonance structure. It's not going to matter. So our next step, I like to think of a nucleophilic attack. So let's go ahead and use this resonance structure right here. So if I bring this O minus down, this pi bond in here is electron rich. It's going to go out and attack something. The only thing that's left is our carbonyl. So we have a aldehyde right here, our benzaldehyde. It's going to go ahead and attack this carbon right in here, okay? This bond's going to get pushed up to there. That's going to give us our next product here. So let's go ahead and give us some more room. So we'll draw an arrow. So this over here still has all of this. This O came down to give us a C double bond O. We have this carbon right there. It formed a new bond with the carbon right here. There's that carbon with an O minus that came up, and our benzene ring. Right, we still got a hydrogen there. So the next thing we're going to do here, let's go ahead and examine what we have so far. So key point I want to make is when this OCH3 grabbed a hydrogen there, we also formed an HOCH3. We formed a methanol. Now that's going to be important because we're going to use that in our next step. So let's go ahead and scroll back down. We have our methanol floating around in solution. Here's our methanol. That can reprotonate our O minus there. Let's go ahead and draw our structure. Got our benzene ring. We have our OH here. Now it looks like we're done, but if we go ahead and react this, let's see what we lose here. We lose some OCH3 minus. from this reaction that happened right here. Okay, so we got some OCH3 floating around as well. Here's that OCH3. If we go ahead and keep this reaction going, perhaps there's some heat involved, we can actually grab an alpha hydrogen, alpha to the carbonyl. The OCH3 here can kick out this H bond, reform a double bond, and kick out our OH minus. Now, OH is typically a bad leaving group, but in this particular case, when we're working with aldol, our OH is going to be a fine leaving group. We are in basic conditions, okay? So our final product is going to look something like this. Let's not forget our new double bond that we just added right here. This is our new double bond, and we just formed some OH, CH3, some methanol, okay? So that's going to go ahead and be our final product. Thanks for tuning in, guys.